Coimbatore. Sir has started as an ARS scientist of ICAR and worked for 24 years at Tamil Nadu Agricultural University since 1997. Sir has completed 25 externally funded projects and 5 sub-projects, and Sir has guided 4 PhDs, 15 MSc and 14 MBA students. Sir has won 26 awards, specifically Manthan South Asia and Pacific Award, E-India Award 2009, E-Asia Award, etc. Sir has visited various countries as part of the academic work, and Sir's significant achievement named M-Velanmai FCMS for performing technology transfer service by extension officers of Tamil Nadu. Sir has published 65 international papers, 75 national articles, 25 popular articles, and 16 textbooks in extension for UG, PG, PhD students. On behalf of the organizing committee, we welcome you for the session, sir, and the session is yours.
Thank you, madam. Am I audible, madam?
Yes, sir, you are.
Okay. I shall try to share my slides. Is it visible, madam?
Not yet, sir.
Oh, okay. Is it visible, madam?
Not yet, sir.
Is it visible, madam?
No, sir.
Oh. Madam. Madam. Hello.
Sir.
Can you share the slides from your side?
Yes, sir. You can send it to Gayatri ma'am so that we could share, sir.
Yesterday I sent by email, madam.
Okay, sir. We'll check and contact you.
Yes, sir. Let me share, sir.
Yeah, you can share.
Sir, pleasant good afternoon, sir. This is Shanmugavadi.
Yes, madam. Good afternoon, madam.
Sir, welcome, sir. Welcome to the session, and we thank you for your readiness to handle the session.
Yeah,
on behalf of the department and the institution, I extend a very warm welcome to you, sir.
Thank you, madam. Thank you.
Thank you, sir.
Sir?
Yes, madam.
Is this slide is visible to you, sir?
I have the slide in my computer. Okay. Yeah.
Is it okay, sir?
I don't know. Yes, madam. Okay.
Okay, sir. Okay, thank you.
Is it in full screen mode, madam?
Yes, sir.
Okay. Okay, thank you very much, madam. Let me start the presentation. I am sorry for the technical glitch. I am unable to share my slides. I'm from Agriculture University, so I'm going to talk about how best we are making use of this technology, that is artificial intelligence, to reach our farming community. So it is our duty to inform the technical advancement in agriculture to our farmers. So that is what the agricultural extension does. Agricultural extension means it is transferring the technology generated from the agriculture university to the farmers field. So we conducted demonstrations in Walden. We conducted demonstration. We had farm and home visit. We had trainings, and we had a consultation and so on. And also we spread the technologies through radio, television, and even through Kisan Call Center. The advisories are given to farmers. Kisan Call Center means it is a telephone service done by this government of India. It is a project run throughout India, and any farmer who has a technical suggestion, whoever wants some technical suggestion in agriculture, they can just ring up 1551 and get the advisories from that center. So it's a Kisan call center. It's a call center service. So like that, we find out new modes of reaching the farmers. So this is now this artificial intelligence technology is another means to reach the farmers. So I'm operating a project called M-Velanmai. M stands for mobile. So we are trying to reach the farmers through this M-Velanmai application. So this application is based on artificial intelligence, machine learning, and deep learning technologies. So if a farmer has downloaded this application, then he can very well open the camera in the app and focus the pest or disease or nutritional disorder symptom images. And once if it is the camera is shown against a symptom, the artificial intelligence takes a role to display the advisories to the farmers. So that is what this project is going to come out with the outcome. So with this brief introduction, let me start this presentation. I hope all of you are computer science faculty. So my presentation will not be so very technical in nature, but it will be very informative. That's all. How best we are making use of artificial intelligence in agriculture. So to that extent, we will just give an exposure. So you may ask, this is the first question, whether farmers will be coming forward to make use of this technology. Yes, the answer will be yes, because you see, And there is a pressing need to use these technologies in agriculture, because you see, India will have to produce 333 metric tons of grains, food grains, that is 50% more by 2050. So that is the projected demand we are having. So to increase it, we have to produce 50% more than what we are producing now. So this elevated increase in demographics is a reason for such a demand in food grain production. Yes, our population is growing at alarming rate, and we have to feed a growing population, for which we have to depend on technologies, one thing. Secondly, the current use of natural resources are highly stressed. So water, everybody knows how important is water for farmers. Electricity, another important resource. Even the soil is a resource. Soil health is also deteriorating due to use of chemical fertilizers and pesticides. So this is going on one side. So out of one, we have only 142 million hectares cultivable area, and about 90 million hectares of land is degraded. You see to what extent even it is more than 50% of the cultivable area is degraded according to National Action Program to combat desertification. So this is a recent data. Only 4% additional land can be brought to feed the growing population. So we are under a constrained situation. We can say that the land available for agriculture is also very minimum. Then another dimension is adding to the challenge of Indian agriculture is the climate change. And climate change is occurring throughout the world, and India is also not an exception for that. And it is also reducing the productivity in agriculture. So because of this climate change, it is impacting the farmers' income also. So it is between 15 to 18% on an average. The losses has been calculated and the farmers' income. So if it is a unirrigated areas, it raises to 20 to 25% also. So that is a range of farmers' income loss incurred due to this climate change in agriculture. And another dimension is from the consumer side, we have this food waste. So food waste is a massive market inefficiency, and it's an environmental threat also. Nearly 40% of the food produced in India is lost or wasted. So this is the status of Indian agriculture. With this scenario, we have to still pull on with agriculture, because one side we have population increase, another side there is a demand for food production. Next slide, please. So these challenges have propelled the need to seek the support of more advanced technologies. Advanced technologies means to reach the farming community with a lot of technical information and know-how and do-how. We need some technologies. It is not sufficient to reach the farmers with the only television or radio or Kisan call center. We need more means. So this artificial intelligence is also a means to promote agriculture among farmers. Next one. So now let us see how this AI has got introduced into agriculture sector. See, at the advent of digital technology, SMS-based generic agro advisories were offered to the farmers. So we started with sending SMS advisories. So SMS advisory means he may be a tomato farmer, but he will be getting information about coconut farming. He may be a paddy farmer, but he will get market information about coconut. So which is totally irrelevant. So this is also happening in the field of agriculture, SMS. So SMS-based generic agro advisories are passed on to farmers. Again, it is supply driven. It is not demand driven. It is not demanded by farmers. A farmer who is cultivating paddy will not demand information about tomato or coconut. But still, Government of India is spending crores and crores of rupees to push this SMS to farmers. Whether it is needed or not, that is immaterial. So this is again, it's going to be a waste exercise. So rather than information support, the farmers need only the decision support. Decision support in the sense which variety I want to cultivate during a particular climatic condition, or agricultural operation can be chosen at an appropriate climatic weather condition prevailing in a particular area. Or can I go for split dose of nitrogen, or can I go for blanket recommendation of nitrogen, phosphorus, and potassium? So this is what you mean by the decision support. So information support is not required by the farmers nowadays. It's only the decisions is the need of the hour for farmers. So in this context, the field of artificial intelligence in agriculture was born when the researchers explored the ways to imitate the human brain. Yes, AI technology is just imitating the experts. So we are making use of AI technology like machine learning, deep learning, so that we train the machine to give the advisories to the farmers. So when the farmer represents the problem in the form of images, then this AI is there to deliver the advisories to the farmers. Yes, it is because, every extension, there is extension officer to give the advisories to farmers in direct mode. So how many extension officers can meet the farmers? We have around 82 lakh farm families in Tamil Nadu state. So it is not possible. We have only around 6,000 agricultural extension officers to give information to farmers directly. So we require some technology to reach the unreached farmers. So this artificial intelligence is a process by which a human can make an intelligent machine to solve the particular problem. Problem means it could be the pest, or it could be a disease, or it could be a weed. Weed means an unwanted crop cultivated being grown naturally into the cropped area. So it is the duty to kill the weeds, or it is a duty to suppress the pest or disease that is occurring in the crop. Okay, so AI is steadily emerging as a part of ICT-based extension evolution to provide decision support to farmers. So it's a new technology, and it is it has the potential to solve the farmer's problem, and because it can give the instant advisories. Rather, if it is an extension officer, the farmer has to take a bus or take his own vehicle to reach the agriculture depot or the agriculture development officer's office and show the symptom and get the recommendation. It's a laborious process. Nowadays, everybody wants information at the tip of their fingers. So mobile phones is there. That's another technology. Again, when we go for smartphones, then this Android application is another technology. Again, when we are going to use this AI, that is again another innovation in agricultural extension to render cost-effective information service to farmers. Next slide, please. So there is another question. Okay, we say that AI technology has got good application in agriculture. Then there is one more question, whether there is appropriate situation, or whether the farmers are ready to adopt this such technology, advanced technology. So yes, answer is again yes. And what are the reasons for the answer is, these are the drivers for AI in agriculture. So there are a lot of points in support of this. See, India's digital transformation is happening at an accelerated rate. So transformation and digital transformation, that is the penetration of this mobile technology or this smartphone technology, is at an alarming rate. See, nowadays everybody is having a cell. You cannot see a person without a mobile phone. That too, you can see multiple number of mobile phone, multiple SIM card in a mobile phone. So many things. If you take a family of 3 people, husband, wife, and children, there will be definitely at least 5 mobile handsets being operated by them. So that is the condition in India, and even in rural scenario also it happens. Every farmer, at least they have these Java phones. Okay, so again, the technology wise also, 5G is going to represent about a 26%, that is 330 million of mobile subscriptions in India by 2026. So 5G, now 4G is there, but 5G, it is also projected to be at a faster rate. It's going to increase in the country. Then the number of smartphone subscriptions is expected to touch more than 1.2 billion by 2026, and currently it is 810 million by 2 years back. So that's what you see, from 810 million to 1.2 billion is the growth rate of these smartphone subscriptions in India. So this data clearly suggests that digital technology, specifically connectivity, will increasingly support agricultural extension service providers to reach out to the farming community. So this has opened a good opportunity for the agricultural extension system, that is the transfer of technology system, to drive innovation in digital extension service and introduce new means of technology transfer to the farmers. So there is good situation, and we can also say that the farmers are showing readiness to go for adoption of these such technologies to access technologies from experts. Next slide, please. So this is a global contribution of AI applications in agriculture. So where do we stand? Yes, India stands third in research on artificial intelligence applications in agriculture with 10.1%, next to China, which is having 24.9%, and the USA 20.7%. So this is a position of India in the global scenario. So we do conduct research on AI applications in agriculture, and we stand third in the world. Next slide, please. Next slide, please. Yes. So again, when you just go down, in which area we are doing this agriculture? Previous slide, please. Previous slide, please. Yes. So which area? When you say agriculture, next slide, please. When we say agriculture, we say we stand third with the 10.1%. Next slide, please. So this is the status within agriculture sector. Which area is topping this research in AI? Means it is the crop management division. So there are various areas in agriculture which can focus on crop or water or soil or livestock. So only these four are the major areas wherein we can find these AI applications. And right now we can see that the crop management is a topic, the research scenario on applications of AI in agriculture. So it is taking to an extent of 68%. Again, when you split up this 68%, you can see the major area is yield prediction. So we create models, AI-based models, to predict the yield of a crop. Then even there are disease detection models, then weed detection, crop recognition, and crop quality. So these are the different areas within the crop management, which is making use of artificial intelligence technology applications. Okay, again, so this is a big thing. Many scientists are working in this crop management area, but I am working in agricultural extension, which is dealing with transferring the technologies to farmers. Next one, please. Now let me tell you about this AI use cases in agriculture. That is how best we are making use of this artificial intelligence technology. I'm not going to show a very extensive use cases, but a few significant cases I'm going to show you. Next slide, please. So even Tamil Nadu Agriculture University, we are using AI applications. Next one, please. So you can see this is one use case, Humani app. It is again, he is a agri graduate from our university, now working in Pacific. So Selvaraj, he is our student. He has created this Humani app. So this is particularly for tackling the pest and disease detection in banana and receive the advisories from the system. So the aim is to develop an AI-based banana disease and pest detection system, Humani app, using a deep convolutional neural network to support banana farmers. So this particular scientist, Selvaraj, he has created this Humani app. So this app is also available online. So you can download this, and using this application, you can solve all these pest and disease problems that is occurring in banana crop. So there'll be banana even in urban areas. You can see every house, you can see people cultivating banana in their backyard. So if they come across some any symptoms, they can make use of this app to get the direct recommendation, which is operating through AI. So what he has done is that he has collected around 18,000 images of various pest and disease that is affecting the banana crop, and so he has also again collected these symptoms samples from Tamil Nadu, Kerala, Africa, and so on. So first he has collected the images, then he has labeled them, labeling, then again the data splitting for training and validation and testing. So he has split the data sets for three purposes. Then he has achieved some accuracy also. Prediction accuracy is more than 90%, and so he is able to detect the pest and disease that is occurring in banana. So this app is created by CET and Biodiversity International, and this is a very successful one. Next slide, please. So this is a methodology we are using. Say 5 major. This is the methodology used by Selvaraj. So 5 major diseases he has identified in this thing, and one pest that is Coimbatore. So these are the 6 major pests affecting the banana crop, and he has covered all these things to for detection and release of advisories to farmers. So first step, he has collected the photographs, good quality photographs. Then he has started to label them using Label IMG software. Then he has used this convolutional neural network architecture, that is ResNet 50, Inception V2, and Mobile Net V1. So these are the models that are tested and found to be successful to predict the symptoms. And he has used a TensorFlow, Python deep learning library, object detection application programming interface with GPU. Then he has used this pre-trained models with the trained with Coco, a data set openly available in TensorFlow detection API zoo models. CNN architecture chosen were retrained using the transfer learning approach from the pre-trained versions. And he has divided the data set into 70, 20, 10 for training, validation, and testing. And the ResNet 50 model performed better, where the prediction accuracy for the entire plant, leaf, pseudostem, and the fruit bunch models was found to be 73 to 97 respectively. So with regard to cut fruits and calm, Inception V2 worked better with the accuracy of 95 and 98% respectively. So this is a methodology he has used to come out with the development of this Humani app. This is one of the very successful one. Next one, please. So this is application you can access, and you can have an experience of this app. So suppose you can just focus the camera against a symptom. So this is Sikataka leaf spot. This symptom So what control measure or what is the technical recommendation we need to handle that can be displayed from this application. Next one, please. Next slide. Yeah. So the other use case, IIT Mandi has developed an app to detect the potato blight. Potato blight is a major disease in potato, and so they have developed this application IIT to detect the potato leaf blight disease. So Central Potato Research Institute CPRI Shimla, they have joined hands with IIT because agriculture people they cannot work alone. They have to work with the computer technocrat to develop such products. Of course, I am also tying up with the IT people so that I am also going to come out with a product in called the M-Velanmai. So this is one thing. So they are able to achieve precision of 98% in the field environment, and it's also working out. And this model is yet to be hosted as a smartphone application. It is under the development stage. Next one, please. So you can also use this AI technology to assess the land suitability, whether the land is suitable for cultivation or not, whether it is suitable for paddy cultivation or ragi cultivation or cotton cultivation or not. So that can be known using the AI technology. So this work is being done in Vellore Institute of Technology. Okay, so this is another use case. Next. So this is done in Tamil Nadu Agricultural University, weed detection. So we can detect the weeds. Weeds are the unwanted plants which has to be suppressed or killed or removed from the crop field. Otherwise, it will start competing with the crop and it will suck all the nutrients, fertilizers, whatever we apply for the main crop. These weeds will exploit that nutrients. So it is our duty to identify the weeds and kill them. So here in the photograph you can see the green ones are the crop and the red ones are the weeds. So using this application we can detect the weeds and we can apply spot application of the weedicide. So we can also go for precision farming, wherein we are not going to spray the entire field. It is only we are just identifying the red spots and try to release the pesticide or the weedicide. So that particular area alone will be we will be using this chemical to suppress the weeds. So in such a way, this technology is a paving way for using that efficiently. So the processed image will be used to train the machine to recognize the red region as weeds and instruct a robot to spray the herbicides only on the weeds. So that's application. Next one, please. So this is an app created by me. It is there in the Play Store also. So when you type TNAU expert system, you can access all this. It is created bilingually. So these are the expert systems on paddy, coconut, ragi, banana, sugarcane, and cattle. So we have created 6 expert systems in 2 languages, English as well as Tamil. You can download it in your mobile phone and you can just check the symptoms and get the recommendations. Okay, next. See, this is a Tamil version of this app that is Nel Nibunar Amaipu, who is missing. You see, it has 3 sections, Payir Maruthuvar, Thagavalagam, Alosagar. So if you access this Payir Maruthuvar, you can just compare the actual symptom, what you observe in the field, with the photograph or the images that is stored in the Payir Maruthuvar section. So Payir Maruthuvar section will have all possible symptoms. So you have to match the symptom with the field level symptom. Once if you match, you can just select that particular image and it will take you to the recommendation section. So that way the farmer can access what he has to do, how he has to control that pest or disease that is occurring in the field. Next one, please. Yeah, so he will get an array of photographs showing the symptom images. Okay, so first he has to select the primary image, then he has to select the secondary image, then the selected pictures will be displayed for confirmation. Yes, if you give yes confirmed means, then it will give the recommendation in the next interface. Next one, please. Yeah, this is the thing. So how you can control it agronomically or chemically or biologically. So these are the control measures. Then you can also get the information regarding the symptoms, how that symptom will appear like and how it is occurring, why that symptom is occurring, and what is that insect which causes the damage symptom and how to control that. All those things, information can be displayed in the expert system. Next one, please. So that is one project which we completed during 2018, and it is there in the public domain also. Anybody can access that expert systems. So now we are doing this M-Velanmai project, which is again a World Bank funded project. So the conceptually, M-Velanmai means it is a AI based bilingual interactive Android mobile application which is being created using deep learning and machine learning technologies to detect the crop damage symptoms. So damage is caused either by insects or diseases, and the farmer will be able to get instant advisories. So this is one advantage, and right now we are creating it for paddy. Once we are successful in paddy, then we will go for all major crops. So that is the idea of this project. This project World Bank has funded for a tune of 2 crores, and we are just about to complete this paddy crop. So the objective of this project is to design and develop an AI-based agricultural extension advisory system called M-Velanmai, which can provide information support to paddy farmers. So once this system is developed, then we'll go for pilot testing, evaluation, and upscaling this product at a Tamil Nadu state level and study the impact among the farmers. Next slide, please. So these are the major insect pests and diseases we are going to tackle through this M-Velanmai application. Okay, so rice stem borer, leaf folder. So these are the symptoms which is caused due to the insect. And on the right hand side, you can see blast, frost, fall smut, leaf blight, sheath rot, brown spot. All those things are caused due to various fungus or bacteria or virus. Okay, so these are the diseases. Next slide, please. So this is architecture you all know very well, which is being used in M-Velanmai. First we go for acquisition, 5-stage process, image enhancement, segmentation, feature extraction, and object detection. Next one, please. So image, so first step, first we go for collecting the images from paddy, particularly paddy images. So this is a data collection. We have a team of BS Agri graduates. They will be going with their own mobile camera as well as SLR camera. So they go right from Kanyakumari to Tirurkoppam, that is near Chennai. So they visit all the agroclimatic zones because it is important to capture the variations in the paddy. There are n number of varieties, more than 50 ruling varieties are there in paddy. So all these varieties has to be captured. Images, say if you say rust is a disease, okay, or smut is a disease again. So the same smut, false smut, what you are saying is the yellow color is the symptom called as a false smut. So the same smut, expression of this false smut will be differently observed in different varieties of paddy. Okay, so it's a very difficult one. So we have to gather all the symptom images that is appearing in paddy varieties. That too, the different stage of the crop also will express the disease in a different way. So we have to gather all the stages of the crop. Stages in the sense vegetative phase or reproductive phase or harvesting stage or a transplanting stage. So these are the various stages in paddy. So we need to collect these symptom images that is appearing in different stages of the crop as well as in the different climate or environmental conditions. Say we have to collect the photograph during early morning hours, during afternoon hours, evening hours, again during a sunny day, again during a rainy season. So it is only the light, reflection of light. The image is nothing but a photo means it is recording the light. Okay. So the image will be, the symptom will be expressed differently in different environmental condition, and even it occurs differently in different varieties of paddy, and also it appears differently in different stages of the crop as well as at the different stages of the disease. Early stage of the disease, later stage of the disease, middle stage of the disease. So lot of variations are there, and all these variations has to be captured. Then only you can build up a good model. So we need high quality images of the crop damage symptoms with varied resolutions, because everybody is using their own cameras. There will be 5 data collectors, means 5 different camera, 5 different mobile phones. Again, they also have this SLR camera as a standard one. So we get the variations through camera also. So this will be captured under diverse backgrounds. That's what I explained it. Backgrounds in the sense, the environmental conditions. So this will be used to represent the variations in the model. Then we try to build up our image library by capturing minimum 1,000 pictures, 1,000 good quality images. To achieve this 1,000 good quality images, we have to have at least 3,000 images. Then only you can filter and get 1,000 images. So this will be collected from real field situation. Again, trying to gather all growth stages and varied environmental conditions from all the pest hotspots of Tamil Nadu. Some pests are more virulent in some parts of Tamil Nadu. So we will be going to all those areas to collect the data. So this is a very tedious job, image acquisition. Next one, please. Once if we get the images, then we have this computer technology, that is we can enhance the images using the software. So strategies are rotation, random zooming, random brightness, random flipping. So we can make use of all these strategies to enhance the number of images. So if you have one image, you can very well do 36 times. So such strategies are available in the software. Next one, please. This is a feature extraction. So every symptom has its own feature, its own texture, its own size. So this is what we are seeing is the paddy is a symptom called as a chaffy seeded grains. So there won't be any rice inside the grain. I mean, there won't be any grain inside this ear. Okay. So it is a waste. So this is occurred due to paddy stem borer, which is a pest that is infecting the crop at the early stage. Okay. So when paddy stem borer is infecting the paddy crop, then this white ear. We call this symptom as white ear. So this will occur. So we have to measure all the ordinates. So the feature has to be extracted. So that is the next step. Then next slide. Then object detection. We have to run different models. More than 30 models are there. So we try to achieve maximum training accuracy and maximum validation accuracy. So such models will be selected. So for every symptom, one model will be the best model, and we have to identify that. So ResNet is the one model which is very ideal for detecting this paddy stem borer, that is white ear symptom. So object detection model yellow V3 we have used, and it has predicted nicely. So this is what, so for every symptom we have to identify which model is the best one. Next one, please. So once if that model is identified, then it can be integrated into the application so that we can make use for detecting the pest at the field level. So data, these are the challenges we are facing in executing the project. So data collection and labeling is a tedious work which has to be done because that is the foundation which the entire work of development of AI stands on this data collection only. Then more training samples, that is large data sets, are needed in order to predict the disease more accurately and improve the generalization. Yes, we have to have more number of samples. So even I said 1,000, but we have gone to even 3,000 images. Then for every symptom, we are collecting 3,000, that too incorporating all the variations. And the paddy is the most difficult crop also, even to collect the data, because there will be snakes in the paddy field. Wet condition, we cannot identify whether there is a snake in the field or not. But we have to enter into the field to collect the data. So again, people are not nowadays, for rain-fed crops, people will be coming, but not for irrigated crops because they have to wet their legs. So this is again another problem of getting the data collectors also is a problem. Then more optimization is needed as a single classifier model lacks in accuracy of result in diverse cases. So if yellow V3 is good to detect the symptom, paddy stem borer, for another say paddy rust or blight, it won't be suitable. So we have to seek different models for different symptoms. Then the speed of detection needs to be faster, which requires high computational resources also. So IT infrastructure is also required at a higher level. So DG 100 studio, all those things, that infrastructure is also needed to do this modeling and all. Only few diseases have been covered, and it needs to be extended to cover more diseases. Again, it's a time-consuming job. Once we are completing with all the major diseases and major tests, then we can release it in the public domain. Next one, please. So we have created this M-Velanmai, and I will just flash some notable features of this application, which is again artificial intelligence based. So it's a bilingual mode of operation. You can operate this application either in English or in Tamil. Then farmers, of course, there are farmers talking English or writing English. So we need to develop this in both the languages. Then query registration, we are taking, the access is not free. Of course, we are not collecting any money for this, but access is restricted for data demand. So you have to provide some data if you want to use this application. We are interested to know who are our users, whether it is the farmers or agriculture professionals or extension officers or agriculture scientists or students. So we are demanding this query registration. Registration is a must. Then once if they enter into the system, then they can raise the query in 3 modes. Either they can capture the image and send it for getting the AI-based advisory, or they can record their voice and send it to the scientist for interaction, or they can just type in SMS format and send to get the advisories. So query registration can be done in all the 3 modes: image, voice, and text. So, but for this prediction of disease pest, weeds, and all sort of symptoms, we are making use of AI largely. For other queries like what is the market price, what is the fertilizer dose I have to use, also for these things, they have to use manual mode only. That is, they have to raise voice or raise the SMS text, and it should be plotted across the scientist to get the advisories. Then instant crop production advisory, protection advisory to farmer is based on artificial intelligence. So that's what I said. Then AI inference validation and query redressal will be done by the TNA scientist. So we are appointing one scientist in every college or research station or Krishi Vigyan Kendra. Every district of Tamil Nadu has either of these three things, either a research station or college or Krishi Vigyan Kendra. So that particular scientist will be giving the advisories to the farmers through this M-Velanmai application. Suppose if the AI is not able to predict, or if it is, if the accuracy, prediction accuracy is less than 90, the recommendation will not be released by the system. So the farmer will be advised to take a photograph and send it to the scientist. So for that purpose, we are appointing query redressal to be done by the TNAU scientist. Suppose if the prediction accuracy is more than 90%, then the recommendation will be released directly by the artificial intelligence based extension system. Then there is a conversational platform which is supported by text and voice input between farmers and TNA scientists. And there is a provision, if the farmer is recording his data of sowing, then from that data of sowing onwards, he will be getting either daily or weekly basis advisories. So these advisories are again weather-based advisories. So the guidance on crop cultivation practices can be given to the farmers. Then e-governance system for project administrators to monitor the utility of the app is also there. So e-governance in the sense how many advisories are accessed by the farmers over a period of time. Say over a period of 3 months, how many advisories have been given to the farmers, or how many farmers are access to the advices from the university or through this artificial intelligence based system. So that can be monitored through the e-governance section of this application. Then we can also, using this application, we can send the risk alerts to farmers in the case of pest outbreak. Suppose if there is a cyclone or if there is a heavy rainfall, then what are the likely pest or disease is going to happen in that area. So that kind of alerts can be given to the farmer so that they get prepared to face that situation easily. Next one, please. So these are the expected outcome from the project. The farmer can get a personalized solution for their pest-related problems. So pest means insect or disease or nutritional disorder or weeds. So they can get the advisories in the form of either text or voice, both English as well as Tamil language. Then it also, this system, M-Velanmai, ensures a two-way communication between farmers and the experts. And within farmers also, they can have interactive platform to share their information among the users. Then M-Velanmai is going to serve as a technology transfer mechanism to address a farmer's problem, and it saves the time and cost of farmers in reaching the experts. So if a farmer is having this M-Velanmai application, then he can very well access all sort of solutions for the problems whatever he faces in the field. So it will save his time in terms of visiting the extension officer or visiting the extension office department, but he can get it right at the farm itself. So that's what it saves the time and cost of farmers in reaching the experts. Then M-Velanmai will cater to the dynamic information needs of the farmers. So dynamic information in the sense of market information, you see, what is the market price of paddy in particular district, or if you take, say there are number of regulated markets in the state, and what is the price of paddy, that to ponni particular variety, or again grade in that variety, what is the grade, grade 1, grade 2, premium grade, standard grade, like that. So what is the market price of paddy declared in each market of Tamil Nadu? So that information can also be accessed using this M-Velanmai. So it gives the dynamic information, and every day we have to update that information. Again, if you take weather information, again it is a dynamic. We have installed automatic weather station in almost 220 blocks of Tamil Nadu, and that is releasing all the data like wind velocity, rainfall, temperature, relative humidity, and so on. So based on that, we can predict the weather and climate of a particular place, and we can provide weather-based technical advisories to the farmers. So this M-Velanmai caters to the dynamic information needs of the farmers. So these are the expected outcome of the project. Next one, please. Yeah, this is the last one. So decision making in future will be a complex mix of human and computer factors, as farmers are seeking ways to improve profitability and efficiency. So whatever technology you give to farmers, the first question will be whether it will fetch me good profit or not. Suppose if I am investing, say, 2,000 rupees to adopt a particular technology, how much I will get in return. So that is the main thing they focus. So whatever technology you give, again, climate is going another factor. So you cannot adopt all the technologies during all seasons or all times. So it's highly dependent on weather. Okay, so you cannot apply a fertilizer during a rainy season, or you cannot apply say pesticides during if the wind velocity is beyond the limits. So again, so we have all our technologies are depending upon the weather conditions of a particular place. So decision making, again, compatible technologies. So some technologies what we use in agriculture will not be compatible if you are going to mix with another technology. So such a complex mix of decisions has to be taken to do a good agriculture, to improve our profitability and efficiency in farming. So this artificial intelligence plays major role in delivering good decisions to the farmers. Then AI-based pest detection smartphone applications can support farmers in monitoring their crops' health by identifying the pest in the field at an early stage. So suppose if we are using this AI technology, it can predict, it can detect well in advance. So you can save your crop as well as save your money, your energy, everything. Okay, so AI technology is highly useful in agriculture. So more pragmatic farming can take place with the support of AI, which helps in improving agricultural yield and reduce the potential environmental risk. However, it is crucial to test and validate the emerging AI applications in agriculture sector, as it is impacted by uncontrolled environmental factors. You might have developed the model, but you see unexpectedly there will be some heavy cyclone or heavy wind velocity or rainfall. Under that condition, whether your model will work or not. So we have to go for validation. Whatever thing we create, some natural or uncontrolled environmental factors may affect the accuracy, and it will be a risk to go for good decisions in agriculture. So this presentation would serve as an eye-opener for agriculture scientists, not only for agriculture scientists, because we depend on computer technologists to develop such systems. Okay, suppose we are interested to, we know the potential of AI, we have the knowledge, but we don't have the skill to put our hands on the computer and work with the system. But we know what has to be done to get an output, get a required output. So that way we have knowledge, but we don't have the skill in operating the computer programs like Python language and so on. So we have to join hands with the computer scientists, and then only we can see wonders in agriculture. So, this presentation is not only an eye-opener for agri-scientists, but also for computer scientists, so that they can join or collaborate to give a better outcome in agriculture. Thank you.